Hello, student friends. I am Dr. Pradeep Devhate, Associate Professor in Chemistry, Shri RLT College of Science, Akola. This is an another video lecture on reactions of aldehydes and ketones, especially the name reactions. Let's start with the first name reaction, that is Mannich reaction. Aliphatic or aromatic ketones containing alpha hydrogen when react with formaldehyde and ammonia or primary amine or secondary amine gives beta amino ketones. Aliphatic or aromatic ketones containing alpha hydrogen when react with formaldehyde and either with ammonia or primary amine or secondary amine gives beta amino ketones. This reaction is known as Mannich reaction, where the product is beta amino ketones. And this product, that is beta amino ketone, is commonly called as Mannich base. The first example of Mannich reaction is reaction of acetone with formaldehyde and dimethylamine in methanol or HCl. Reaction of acetone with formaldehyde and dimethylamine. See the reaction. When acetone is reacted with formaldehyde and dimethylamine in methanol or hydrochloric acid, it gives 4 dimethylamino 2 butanone. 4 dimethylamino 2 butanone, that is beta amino ketone. During the reaction, there is simple loss of water molecule takes place. Next example is reaction of acetophenone with formaldehyde and dimethylamine using solvent methanol or HCl. Reaction of acetophenone with formaldehyde and dimethylamine. Here also there is formation of Mannich base, that is 3 dimethylamino 1 phenyl 1 propanone. 3 dimethylamino 1 phenyl 1 propanone by the reaction of acetophenone with formaldehyde and dimethylamine. Here methanol or hydrochloric acid can be used as solvent. This is the second reaction, second example. Instead of secondary amine, we may use primary amine in Mannich reaction. Example of that are reactions of acetone and acetophenone with formaldehyde and methylamine, that is the primary amine. See the reactions. Acetone reacts with formaldehyde and 4-methylamine, that is primary amine, in presence of methanol or HCl, so as to get the Mannich base 4-methylamino 2-butanone. Formation of Mannich base 4-methylamino 2-butanone. In next reaction, there is just change of ketone. Instead of acetone, acetophenone is used. Here the product is 3-methylamino 1-phenyl 1-propanone. The product, that is Mannich base, is 3-methylamino 1-phenyl 1 propanol. During these reactions, the loss of water molecule takes place. Now, the examples related to the use of ammonia instead of using the primary or secondary amines. Reaction of acetone and acetophenone with formaldehyde and ammonia in presence of methanol or hydrochloric acid. Reaction of acetone and acetophenone with formaldehyde and ammonia instead of primary amines or the secondary amines. See the first reaction. Acetone, formaldehyde and ammonia reacts with each other to form 4-amino-2-butanone. Acetone, formaldehyde and ammonia reacts with each other to form 4-amino-2-butanone. In second reaction, acetophenone is reacted with formaldehyde and ammonia. Here, the product is 3-amino 1-phenyl 1-propanol. 3-amino 1-phenyl 1-propanol. These are some examples of managed reactions where we may use ammonia or primary amines, or we may use the secondary amines so as to form the managed base. Next one is benzoin condensation. Benzoin condensation. Aromatic aldehydes do not containing alpha hydrogen on treatment with aqueous alcoholic potassium cyanide or aqueous alcoholic sodium cyanide undergoes condensation to give alpha hydroxy ketones. Aromatic aldehydes do not containing alpha hydrogen on treatment with aqueous alcoholic potassium cyanide or sodium cyanide undergoes condensation to give alpha hydroxy ketones. This reaction is known as benzoin condensation. This is the benzoin condensation. The product alpha hydroxy ketone is commonly called as benzoin. Alpha hydroxy ketone is nothing but the benzoin. See the example. Reaction of benzaldehyde with aqueous ethanolic solution of potassium cyanide or sodium cyanide. When benzaldehyde is reacted with aqueous ethanolic solution of potassium cyanide or the solution of sodium cyanide, condensation of two molecules of benzaldehyde takes place and there is formation of alpha hydroxy ketone called as benzoin. Condensation of two molecules of benzaldehyde takes place and there is formation of alpha hydroxy ketone. During the reaction, cation or NaCN, that is potassium cyanide or sodium cyanide, get dissociates to K positive or Na positive and Cn negative ions. Cation get dissociated into K positive and Cn negative, and if we use the NaCN, then it get dissociated into Na positive and Cn negative. This Cn negative ion attacks on carbonyl carbon of benzaldehyde so as to form the nucleophile. It combines with another molecule of benzaldehyde, transfer of proton and loss of cyanide anion takes place to form the final product, that is benzoin. This is the benzoin condensation. The last one is aldol condensation. aldol condensation. Aliphatic or aromatic aldehydes and ketones containing alpha hydrogen undergo self addition, or we can say condensation, in presence of a base to give beta hydroxy aldehydes called as aldols, or it gives beta hydroxy ketones called as ketols. Aliphatic or aromatic aldehydes and ketones containing alpha hydrogen undergo self addition in presence of a base to give beta hydroxy aldehydes or the beta hydroxy ketones. Beta hydroxy aldehydes are commonly called as aldols, whereas beta hydroxy ketones are called as the ketols. This reaction is known as aldol condensation. The example is reaction of benzyl acetaldehyde with dilute sodium hydroxide or sodium carbonate. Reaction of acetaldehyde with dilute sodium hydroxide or sodium carbonate. When acetaldehyde is heated in presence of dilute sodium hydroxide or sodium carbonate, condensation of two molecules of acetaldehyde takes place to give beta hydroxy butyraldehyde, that is aldol. Here condensation of two molecules of acetaldehyde takes place when acetaldehyde is heated in presence of dilute sodium hydroxide or sodium carbonate to give beta hydroxy butyraldehyde, which is called as the aldol. See the reaction. Acetaldehyde reacts with dilute NaOH or Na2CO3 and the product is beta hydroxy butyraldehyde, or we may call that as 3-hydroxybutanol. This aldol on warming with dilute acid loses water molecule to form alpha beta unsaturated carbonyl compounds. What's the reaction? When 3-hydroxybutanol is warm, it loses water molecule to form crotonaldehyde, which is alpha beta unsaturated carbonyl compound. Aldols always on warming with dilute acid loses water molecule and forms alpha beta unsaturated carbonyl compound, and here the example of formation of crotonaldehyde is given, which is formed from the aldol. Next examples are of reactions of acetone and acetophenone with dilute NaOH or Na2CO3, that is dilute sodium hydroxide or sodium carbonate. When acetone or acetophenone is heated in presence of dilute sodium hydroxide or sodium carbonate, beta hydroxy ketone is obtained. When we use acetone, the product is 4-hydroxy 4-methyl 2-pentanone, while by using acetophenone, the product is 3-hydroxy 1,3-diphenyl 1-butanone. These are some examples of aldol condensation. Here also, during reaction, initially NaOH get dissociate to form Na positive and OH negative ions. The OH negative ions abstract protons from first molecule of aldehyde or ketone to form the anion, which combines with second molecule of aldehyde or ketone, then abstract the proton to get the product, that is aldol or ketone. Aldol or ketone. Dear students, this is all about the reactions of aldehydes and ketones. Please do concentrate on your studies. Have a good day. Thank you.